India's Advanced Medium Combat Aircraft Program, the country's most ambitious endeavor to develop an indigenous 5th-generation stealth multi-role fighter, has reached a pivotal milestone this week. 3 private sector consortiums have been shortlisted for prototype development, effectively excluding state-owned Hindustan Aeronautics Limited. The shortlisted entities, Tata Advanced Systems Limited, Larsen and Toubro, and Bharat Forge, advanced after a rigorous technical evaluation of bids submitted in response to the Aeronautical Development Agency's expression of interest issued in June 2025. This outcome marks the first time a major Indian combat aircraft program will proceed without HAL as the primary integrator, signaling a deliberate policy shift towards competitive private sector involvement. The AMCA is designed as a twin-engine supersonic stealth fighter with advanced features including low radar cross-section, internal weapons bays, super cruise capability, sensor fusion, and networked warfare integration. Weighing approximately 25 tons, it aims to replace aging fleets like the Su-30 MKI and position India among the select nations, the United States, China, and Russia, capable of fielding operational 5th-generation aircraft. Approved by the Cabinet Committee on Security in 2024, the program received an initial allocation of 15,000 crore rupees for full-scale engineering development, focusing on building 5 flying prototypes and 1 structural test specimen. The ADA, under the Defense Research and Development Organization, leads design and systems integration, while the selected industry partner will handle manufacturing, assembly, and certification support. HAL's exclusion matters profoundly for the AMCA program. Historically, HAL has dominated Indian military aviation manufacturing, serving as the default production agency for fighters since independence. Its track record, while delivering platforms like the Tejas, has been marred by delays. The Tejas program, sanctioned in 2001, achieved initial operational clearance only in 2013, with full deliveries still ongoing. By opening the program to private competition, the government aims to inject efficiency, innovation, and accountability. Private firms bring modern project management practices, global supply chain expertise, and investments in advanced facilities. For instance, Tata has experience in aerospace structures through partnerships with Lockheed Martin and Airbus. L&T excels in precision engineering and defense systems. Bharat Forge specializes in high-strength materials critical for stealth airframes. This competitive model reduces risks of single-point failures, accelerates technology absorption, and aligns with the Atmanirbhar Bharat initiative to build a robust domestic defense industrial base. The shift addresses capacity constraints at HAL, allowing it to focus on clearing its Rs 1 lakh crore plus order book, including 97 additional Tejas MKI-1A jets and helicopter production. It also promotes technology transfer and skill development across the ecosystem, fostering multiple centers of excellence rather than relying on one entity. Critically, it mitigates delays that could compromise operational timelines amid regional threats from China's J-20 and potential Pakistani acquisitions of 5th-generation platforms. Faster prototype development could enable India to achieve stealth fighter capability by the mid-2030s, enhancing air dominance in contested environments. Once the final developer is selected, expected within 3 months following submission of detailed commercial proposals, the program will enter its most intensive phase. The winning consortium will form a special-purpose vehicle with ADA for collaborative execution. Detailed design freeze incorporating stealth coatings, diverter-less supersonic inlets, and advanced avionics will precede prototype construction. Initial prototypes will use GE F414 engines with 98 kN thrust, transitioning to an indigenous 110 to 120 kN engine co-developed by Gas Turbine Research Establishment and a foreign partner, potentially Safran. Prototype rollout is targeted for 2028 to 2029, with the first flight by 2029 to 2030. This will be followed by extensive flight testing, including weapons integration, stealth validation, and super cruise trials spanning 8 to 10 years. Certification by the Center for Military Airworthiness and Certification will pave the way for low-rate initial production by 2032 to 2033 and full-scale manufacturing by 2035. The Indian Air Force plans an initial order of 120 to 150 aircraft in Mk1 configuration, with a more advanced Mk2 variant featuring more indigenous content and enhanced capabilities.
Challenges ahead include mastering stealth technologies such as radar-absorbent materials and serpentine intakes, which demand precision manufacturing tolerances. Supply chain integration for critical subsystems, active electronically scanned array radar, infrared search and track systems, and electronic warfare suites will require seamless collaboration with domestic firms like Bharat Electronics and international risk-sharing partners. Funding beyond the initial Rs 15,000 crore, potentially exceeding Rs 60,000 crore for full development, will test fiscal priorities. Geopolitical factors, including engine technology transfer restrictions, remain hurdles. Ultimately, selecting a private lead integrator could transform India's defense landscape, creating a template for future programs like 6th-generation fighters or unmanned combat systems. Success would not only bolster national security, but also position Indian firms for exports, contributing to strategic autonomy in an era of evolving aerial threats.